now let's move to the next one, the sorting. When we design the sorting algorithm, it is much beautiful than the searching algorithm, but due to the time limitation, we just have like 25 minutes left, so we cannot go to quite detail for each sorting algorithm. So we just mention some concepts, the main idea of these sorting algorithms, and you need to take some spare time after class to get to understand all these algorithms and trying to apply them to different questions by yourself. Just do more practice, okay? Okay, so sorting, we quickly define it. Sorting is to arrange items in a collection so that there is an ordering in one or more of the fields in the item. So make it in order, okay? So we need to have some sort key. Do you remember the sorting array has a unique key? So we have defined the sort key as a field or fields on which the ordering is best. And the sorting algorithm means algorithm that order the items in the collection based on the sort array, sort key, okay? Based on sort key to sorting it. That kind of algorithms, we call it sorting. So we can say, why is sorting important? This is quite an interesting question and very open question. So you can consider it after class, okay? And I hope next class, some of you could discuss to present some of your opinions at the beginning of our next class, okay? So of course, sorting is quite important. So a lot of scientists devoted a lot of time to design a much better sorting algorithm. So how to define better? That is two different possibilities. First possibility is the time or the iterations, how many steps you need is decreased. That is the time complexity is decreased. So that means you can solve this problem. You can sort this in a very quick time, in very high efficiency. That's one dimension we can say the algorithm is better. Another dimension is that you need smaller space for it. Because we have said the storage in the computer is also important. So if you need a library to storage all the data, or you just use a backpack to storage your data, that's quite different. So that is a kind of improvement, or you can define it better through the space complexity. So through two dimensions, okay? So firstly, we would introduce a sorting algorithm named as selection sorting. Okay, selection sorting, it is quite simple in fact. So for example, you have an array and you have some number in it. Each time, oh, I'm sorry, I listed a sorted array. If it is sorted, we don't need to do sorting again, right? So let me list some unsorted numbers in here. Okay. So selection array is quite simple. That is, each time, each step, you find the smallest number in this array. For example, 3, you find it the smallest one. You write it in another paper, in another table. And then you find the smallest one and write it here. Find the smallest one right 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 here. And find the smallest one right here. Then it is sorted. The task is finished. Okay, so we can define it as the following. So the question is given a list of names. This is number, okay? Name is also okay. So if the question is put them in the alphabet order, then what do you do? Firstly, find the name that comes first in the alphabet and write it on a second sheet of paper. Okay? Similar like here, find the smallest number. Okay? Find the number comes from first in the alphabet and come and cross out the name of the original list. Each time you list here, then you cross it out. Continue this cycle, okay, it's a loop, until all the name on the original list has been crossed out and written onto the second list, okay? All of them has listed into the second order has crossed out. And the second list contains the same items but in a sorted order, right? So this is an example. So this is how selection sorting is done. So we can find, firstly, we can do a little bit improvement. In this method, we need to another array. And each time you write it on another paper or in another array, anyway, you need an additional array. But we can find, in fact, each time, I'll write another one because the first beginning is same order. Okay, for example, if I find the smallest one, I write it in another paper. You need an additional array. It's a space waste. In fact, I can just swap it with the beginning number. That is also okay, right? So we can do a slight adjustment to improve the space. So as you cross a name off the original list, a new space, a free space opens up. Because if you cross up it, then here is a free space, right? So instead of writing the value found on a second list, exchange it with the value currently in the position where the crossed off item should go. Okay? So we can find in this procedure, we need to do 3 things. Firstly is each time you need to find the smallest number. Okay? Find the smallest number. You need to find the smallest number. Then, if you find it, you need to swap it with the first unsorted item, right? So find the smallest one. Find the smallest one first. Then swap it with the second. And do a loop until all has been done. So if we consider it in the abstraction viewpoint, you can just write the pseudocode like this. The selection sorting algorithm can be defined as set first unsorted to 0 because you need a flag to mark which position to exchange. For example, it's 4 to 6. You can find this one and change here. Then you get 2, 4, 6. For example, 3. Okay, 3. And then you find this one. So you change. You change here, not here, right? So this is the first unsorted element. You need to mark this number. So we use a first unsorted variable to mark this. So first set it to 0 from the first beginning 0 position. And each time, if it is not sorted yet, find the smallest number and swap it with the first unsorted number, and then move the first unsorted number to the next, to the right next. So this is a brief description of this selection sort. But we can find how to find the smallest unsorted number, how to swap it with different element. This is not an item the computer can do directly. So this, we need to algorithm for this task one more time. Okay, so firstly we listed how we find the smallest unsorted number. How do you find the smallest number in an array? You compare, right? You compare from the first one to the last one. So firstly we set an index of smallest. You compare, we set a smallest index of smallest. First, let's set it to the first one, the first unsorted. And then we set an index to this first unsorted plus 1. Okay, we set an index. And when we do a loop, as if this index is smaller than the length, we do the loop. If the data in this index is smaller than the data in the smallest marked value, then you find the new smallest one, right? Set this index to this smallest one. And then move to the next. Okay? So move the index to the next. So you check one by one to find the smallest one. Each time you compare two. And you find the smallest one and put it in this smallest flag. And you move to the next one. And then you check the next one and the smallest one. And then you put the smallest one between them in this flag. And you move to the next one and compare one more time. So this is a very simple way to find the smallest unsorted number. Okay? And then you need to swap them, remember? Swap the first unsorted with the smallest as if you find it. How to swap? So first we set a flag, a template item to this data first unsorted. Okay? Because you remember which one you exchange, the first unsorted and the smallest, right? So you need this data, the first unsorted data. And then you set this first unsorted data to data the smallest one. So put this data in this position. And you need to set this data to, firstly, you put this data. You put another variable, you put it here. And then you use this number to replace it. And then you put here to in this position so that you can do the swap. So as if you do the swap, you need an additional variable. Okay? So that is a full procedure of a selection sort. So let's show a quick example here. Okay? So firstly, the smallest one you find is n. You put it in the you swap it with the first unsorted number. If it is sorted, we use gray. Okay, so the first unsorted move here, and then you find one more time the smallest one, and swap it with the first unsorted. So here is sorted. So the first unsorted moved to here, and you find the smallest one is this one. So just keep it in its original place. So similar here, okay? Find the smallest one and swap it with the first unsorted element. So it's finally all has been sorted. It's a selection sort.